Welcome to This Explainer. Today, we're unpacking a seriously incredible story. We're looking at a case where a defendant actually used complex systems physics to fight a criminal charge. Yeah, you heard that right. It's this wild, fascinating look at what exactly happens when highly theoretical physics unexpectedly collides with criminal law.
So can a mathematical formula literally prove your innocence in a court of law? Well, what's so interesting here is that one researcher attempted to do exactly that. Instead of just relying on your standard legal defense, he turned his entire trial into this fascinating forensic deconstruction, using the laws of physics. It gives us a really compelling look at what happens when you try to apply hard science to, subjective legal accusations.
All right, here's our roadmap for today. We'll start with the Retweet criminal case, then look at the physics of public chaos and Avalanche dynamics. After that, we'll break down the actual mathematical defense, evaluate the science, and finally wrap up with systemic risk and hubs. Let's get right into it.
Section 1. The Retweet criminal case.
So looking at the timeline from the court documents, things moved pretty fast. Dr. Chen was arrested in September of 2022. By January 2023, he's facing prosecution, and then in April, right after his trial, he was sentenced to 1 year and 8 months in prison. His appeal, swiftly rejected just a month later in May. This rapid-fire succession of legal events really sets the stage for what became a highly unusual pushback from the defendant.
Now, Dr. Chen was officially accused of, quote, picking quarrels and provoking trouble. But the core charge, he was using a VPN to access Twitter and retweet content. The prosecution argued he was knowingly spreading false information, and the court ruled that his actions caused severe public disorder. But here's the kicker. The evidence against him was purely just his sporadic retweets spread out over several years.
Moving on to Section 2, Physics of Public Chaos. To defend himself, Dr. Chen decided to bring science right into the courtroom. Okay, the absolutely crucial thing to understand here is self-organized criticality, or SOC. Proposed by the physicist Per Bach back in the late 1980s, this is a very standard framework in complex systems theory. Basically, it describes how certain open complex systems naturally and spontaneously evolve to a tipping point, a critical state. And when a system is in this state, it's so incredibly sensitive that just one microscopic event can trigger a massive, totally unpredictable chain reaction. Per Bach actually used this famous sandpile model, which brilliantly illustrates the concept. Imagine sand dropping slowly, just grain by grain, onto a flat surface. A pile starts to form, right? It gets steeper and steeper, until eventually it hits that critical state. At that exact point, dropping just one single, tiny grain of sand can cause a massive avalanche. Now think about your own social media feed. Just like that sand pile, a social network can accumulate all this invisible tension until one tiny, random post triggers a massive viral cascade. Which brings us to Section 3, Avalanche Dynamics Explained. Let's see how this builds on that sand pile metaphor. So, to measure how information actually cascades through a network like Twitter, scientists use a branching process, often called the Galton-Watson process. You can think of it kind of like a family tree. One post is the parent, and every retweet is an offspring. The crucial metric here is governed by a mathematical variable called m. This m represents the average branching factor. So essentially, it's the average number of new shares or retweets a single post generates. As you can see, the fate of any piece of information all comes down to that branching factor, m. If m is less than 1, the system is subcritical, meaning the cascade just rapidly dies out. If it exactly equals 1, boom, you hit that critical state, a power law avalanche. And if m is greater than 1, well then you enter the supercritical zone, which means explosive, massive global spread. All right, Section 4, the mathematical defense. Let's see exactly how Dr. Chen tested the prosecution's claims. The forensic data for Dr. Chen's defense was actually remarkably simple. His Twitter account had fewer than 100 followers. Many of those were inactive, and his interaction rate was essentially 0. He was literally mounting an advanced theoretical physics defense precisely because nobody was engaging with his content. So, Dr. Chen's logical proof was pretty airtight. He argued that for the court's claim of severe chaos to actually be true, the branching factor, that m we talked about, had to be at least 1. But, as an edge node with almost 0 interactions, his personal branching factor was practically 0. He was deeply subcritical. Therefore, mathematically speaking, according to the extinction theorem, any avalanche starting from his account was inevitably destined to die out.
And because his cascade was mathematically die-out, Dr. Chen essentially called the court's bluff using math. He boldly stated that the court's claim of severe social disorder lacked any empirical entity. I mean, without data showing actual avalanche-scale metrics or a provable chain of causation from his specific retweets to real-world chaos, he argued the legal charge was just a completely unscientific pseudo-proposition.
Section 5, Evaluating the Science. Let's test the validity of these claims. Now, the source documents reveal that his fascinating 20,000-word defense manuscript, which, by the way, was written entirely from a prison cell, was analyzed by advanced AI models, including ChatGPT and Grok, just to impartially evaluate the math. And what did the AI find? Well, it evaluated the physics and confirmed that Dr. Chen's application of the theory was highly accurate and totally scientifically mainstream. His core logic, that subcritical edge nodes do not cause system-wide avalanches, is strictly mathematically correct. The AI concluded that utilizing self-organized criticality in avalanche dynamics is a completely valid and robust method for analyzing Twitter cascades. However, the AI evaluation did point out a minor yet really fascinating scientific flaw in his phrasing. Dr. Chen argued it was absolutely impossible for him to cause chaos, but in complex systems theory, because of extreme, unpredictable long-tail events, you can actually never say the probability is an absolute flat zero. The strictly correct scientific phrasing should just be that the probability approaches zero. Furthermore, the AI pointed out a pretty significant gap in the evidence. You see, self-organized criticality is a property of the whole system, not just an individual node. So while Dr. Chen flawlessly proved his own node was subcritical, he completely lacked the massive system-level data needed to prove that the overall network wasn't already sitting in a highly sensitive critical state, just waiting for that final grain of sand. This brings us to Section 6, Systemic Risk and Hubs. This is where we look at where the true danger actually lies. Addressing that very gap about the state of the whole system leads to this absolutely brilliant twist in Dr. Chen's thesis. He contrasted peripheral nodes, everyday users like himself with minimal connective impact, against what we call hub nodes. In network physics, hub nodes are the heavyweights. We're talking major media outlets, large institutions, or state authorities. Because their branching factor is massively greater than 1, they pose a supercritical risk, with a really high capacity to trigger global avalanches. So by applying network physics, Dr. Chen totally flipped the accusation on its head. He argued that high-impact judicial or state actions act as these massive hub nodes. When these powerful hubs act, especially if they act aggressively or without clear evidence, they inadvertently pile up immense tension in that social sandpile we talked about earlier. It's like someone dropping heavy clumps of sand all at once. By eroding internal structural stability, he argued that these institutions actually become the true drivers pushing the entire system toward that unstable critical state. Ultimately, this explainer leaves us with a really profound question right at the intersection of physics and justice. If our complex social systems naturally build toward these chaotic, critical states, can the legal system ever truly pinpoint the single grain of sand responsible for an avalanche? Or are we just wasting time pointing fingers at the peripheral edges, while completely ignoring the massive hubs that actually have the power to shake the foundations of our world?